Okay, so so this is a problem from Stewart 9th edition, section 7.2, number 18. So, the question is to integrate tangent square x times cosine to the third x dx. So we're just going to talk over this to see how we might be able to do this.
Now, the first thing that I'm thinking about is I want to do a substitution on this.
Sure.
So if I can turn it into all sines times one cosine,
Okay.
then I can do u sub equals sine.
Uh-huh.
Or if I can make it all cosines times one sine,
Uh-huh.
then I can do u sub equals a cosine. So those are my plans.
Yeah, so that sounds good. So the question is, how do we do it?
Right, and the tan squared here,
Uh-huh.
that sends a signal, right?
Yeah.
I'm thinking about that tan squared plus 1 equals sec squared identity.
Yeah, sure. But, okay, let's try.
Okay, so you're thinking the same idea?
I also thought about maybe tangent is sine or cosine. So tangent squared, we could replace it with sine square or cosine square. Everything is in terms of sine and cosine, but I don't know whether that will work out in terms of all sine and then cosine or all cosine and then sine. But those are the two choices I can think of.
Okay, yeah, so we have options.
Yeah.
Let's try the first thing first.
Sure.
So I'm going to switch this tan squared out. I'm going to switch it for, so tan squared plus 1 equals sec squared.
Yeah.
I'm going to switch that out for sec squared minus 1.
Uh-huh.
So now everything's in terms of, oh, nice, secant's 1 over
1 over
cosine.
cosine, okay.
So
Everything is in terms of cosine.
let's, I guess, distribute that cosine
Sure.
cubed across.
Sure.
So if sec squared is, if secant's 1 over cosine,
Uh-huh.
then that's going to be 1 over cos squared.
Yes.
So when I distribute this across this
Uh-huh.
minus sign,
Uh-huh.
that's just going to leave me with 1 cosine.
1 cosine, yes.
And it is going to leave me with a cos
Sine
cubed here.
yeah.
Okay, so we did the distribution.
Yeah. I mean,
Oh, let's focus back on what this looks like.
all cosines, but not there is no sine there.
Right, so let's keep one of those cosines?
Yeah, sure.
Okay, so,
Yeah, and there is you can factor. Yeah, so you can factor out the cosine from there, one cosine from there.
or I guess I could have only multiplied 2 of the cosines
Yeah,
through
it's
and left
true,
the other
but
one, right?
yeah,
Maybe that would have been better.
Yeah,
So that means this is a 1,
1.
and that's a squared.
Yes.
Okay, so now,
Oh well, 1 minus cosine square, right?
Yeah.
So that we can replace with sine square.
nice, okay. So if I replace that with sine squared,
Uh-huh.
now I've got what I wanted. I've
Yeah.
got all sines times cosine.
Yeah, and
Okay.
then we can do u is equal to sine.
Okay, before I do this substitution though,
Yeah.
let's just pause for a second.
Sure.
The trig identities are making my integration easier.
Yes.
Right? They're solving the problem.
Yeah.
So knowing all these trig identities ahead of
Yes.
time
Yeah.
is going to make your integration in calculus just
Yeah.
easier.
Yes, exactly.
Even before, so we have to learn that before we get to
Before.
this section.
Exactly, and even there, I feel like if you just know sine square plus cosine square x is 1, you can get the other identities by dividing by either sine or cosine.
Right, yes, yeah.
Yeah.
So I'm going to make my substitution.
Yes.
I need to differentiate my substitution.
Yeah.
The way I write it, then I switch out dx is equal to du divided by cos x.
Okay.
I know that some people do it
Yeah.
where they solve for the du equals
Du, yeah.
cos x dx.
Yeah, I do it that way, but both are
Oh.
same. Yeah.
Okay.
Yeah.
Yeah, both will end up being the same.
Yeah.
So when I do this substitution, now I've got integrate u squared
Uh huh.
and cos x dx is equal to du. I can do
Yeah.
it your way, it's easier typing when I
That's
do
true.
that substitution. And now
It's,
We're good
it's
to
a
integrate.
third over 3, yeah.
It's a straight add one to the exponent,
Yeah.
divide by what's up top,
Yeah. Plus C.
plus C. Of course, I'm not done yet.
No.
Because now I got to put back
Go
in
back-
for
go back
what
to-
U
yeah.
is equal to.
Yeah.
So that's going to be cosine. No,
No,
we made
sine.
U equal sine.
Yeah.
Sine cubed. Over 3 plus C.
Yeah.
Okay, so this is this
Yes.
with an equals.
Equals. Yeah.
And we figured it out
By
with
just
our-
going through the identities there, right, and then just use substitution. So
Yeah.
what would have happened if? So do you think replacing that tangent square by sine square or cosine square, do you think that would have worked? Or-
I th- yeah, maybe, because that would have been sine squared divided by cos squared.
Uh-huh.
The cos squared would have canceled 2 on the bottom.
Yes.
So that would have also,
also end up with the same integral towards the end.
Yeah.
right? Yeah.
so both of those are
Both of
valid.
the work, but in general, at least when I do it, whenever I see the tangent square, I always tend to replace that using secant square, because that's mostly what happens when I try the integrals, the way you did it. Right?
Yeah, that's, so I agree with you. I would have went with that way
Yeah.
first. The way that we did it
Yeah.
is the way that I would have tried first.
Yeah.
But you always have that other way kind of in
Sure.
your back pocket as,
Yeah.
as another option.
Yeah.
One of the things I do see though,
Yeah.
whenever I'm doing an integration, my next sort of thought is, all right, there's my answer.
Yes.
I should differentiate my
Differentiate.
answer, get my question.
Yeah.
But if I differentiate this, chain rule 3 comes down, cancels the 3 on the bottom.
Yeah.
Let's actually,
Yeah,
I'm
let's
going
try
to take
that.
this and differentiate.
Yeah.
I'm going to rewrite this
Uh-huh.
just to be like super, super clear. That's what that means.
Yes.
And now it's sine
Yeah.
inside the cube.
Yeah.
So the 3 is going to come down,
Mhm.
subtract. So let's differentiate this. The chain rule. The 3
Yes.
comes down, subtracts 1 from the exponent. There's a times the derivative of what's inside. The derivative of sine is cosine.
Yeah.
The derivative of
Goes-
constant is
goes
0.
away. And 3 cancels
The
out.
3 cancels out.
Yeah.
So then this, when I cancel the 3 out, okay, if this is another use for identities, right?
Yes. Yes.
Two math profs did this, so I'm pretty sure that we got the right answer.
I hope so.
But this
Yeah.
doesn't look like this.
Yeah. However, when we the function we just integrated, if you look at the integrand we did towards the bottom there, it was that.
Right, so our integration is correct.
Yeah.
To make it back into the question
Yeah.
though,
Yeah.
what would we, like, how would we turn this back
Oh, I see.
into the integrand?
Yeah, so the way I'm thinking of it, so that we have a sine square there, so we could replace that with 1 minus cosine square.
Yeah,
Or maybe multiply and divide by cosine square.
I think I agree with you there. That would be, so essentially multiplying by 1.
One, yes.
But I want that cos squared on the bottom, so.
Yeah. And we need the cosine cube as well, because that's what we started with.
Right, and now if that'll be cos times cos squared, that'll be cos cubed.
Yeah.
Sine squared over cos squared,
And
that'll be
tangent
the tan
squared.
squared.
Yeah.
So,
We get that, yeah, get that back, yeah, yeah. Yeah.
so I guess what's the take home from this?
I guess don't panic.
Sure. Yeah.
Right? And as you laid it out in the beginning, when we try to do this integration, because of the cosine there, we probably want all sine and then cosine, or all cosine and then sine. So you can do the U substitution. And just a matter of trying to use the trig identities to kind of make it in that format. And we saw 2 different ways to do it.
Right, and we actually, I think we maybe didn't choose the easiest way.
Probably not, but it's a more standard way though.
I
Whenever
agree,
I see
yeah.
the tangent square, I want to kind of use the secant there.
Cool.
Sounds good.